How is it that two objects can travel exactly the same distance yet have completely different displacements? Well, the answer is in one of the important ideas in physics, which is the idea of scalars and vectors. So a scalar is something that has a magnitude only. So it would tell us how much of something there is, but it wouldn't tell us in which direction. So some examples of scalars would be speed, distance, time, mass, temperature. So if a car was travelling at 20 metres per second, that's a scalar. I've given you a speed, but I haven't told you where it's going. Now a vector is something that has a magnitude and a direction. So if I told you a car was travelling at 20 metres per second north, that's a vector. I've given you the size or the magnitude, I've told you the speed, but I've also given you the direction it's travelling in. So for a vector, it needs to have a size and a magnitude. And some of the important ones would be acceleration, displacement, velocity. Now, this is where it gets interesting. If you walked 10 metres north and then turned around and walked 10 metres south, your distance travelled is 20 metres. However, your displacement is 0. You're exactly where you started. So, displacement is a vector, distance is a scalar. And you can do the same for speed and velocity. Speed is a scalar, it tells us how fast something's going in, but velocity is a vector. It is a speed with a direction. So, in summary, a scalar has a magnitude or a size of something, and a vector has a magnitude and a direction, a size and a direction.